Hey guys, welcome back to my channel. I know it's been a while, but I'm back. School has caught up to me just a bit. That's why I haven't been posting any videos. But for today, I will be doing a video on representing data. So I want you guys to stay tuned. Remember to like, share, and subscribe. Now let's get into it. Graphs are very common. When you collect and record data, you can represent it in a diagram. And this diagram is known as a graph. No, not any graph can go with any data. The type of graph that you use depends on the type of data that you want to represent. For example, discrete data is best represented using bar charts. And for note, discrete data is based on counts, so only a finite number of values is possible. It can only take certain values. An example of discrete data is the number of students in a class. You cannot have half of a student. You can only have one student, two students, three students, not 3.5. So this is a form of discrete data. So temperature graphs are usually line graphs because the data is continuous. Temperature is continually changing. It either drops by degrees Celsius, or it increases by degrees Celsius, or it drops by many degrees Celsius. It's very fluctuating. It's not constant. So the data is continuous. When you are graphing percentages of a distribution, a pie chart would be suitable because a pie chart is all about percentages. How about when you have two variables, such as the marks in a maths test and the marks in a science test? Then a scatter diagram could be used. Alright, so different information is represented on different graphs. So it's very good to know that. Let's talk about our graphs now. What makes a graph? Well, a graph must have certain properties for it to be classified as a graph. Now, you need to know that all graphs need salt. All graphs need salt? What does that mean? Well, SALT is just an acronym. S means scale, A means axis, L means labels, and T means title. Now, some of the graphs that you'll be seeing as examples do not necessarily have all the components of SALT, but it's just for visual purposes. But when you are doing your graph, ensure that your graph has SALT, a scale, axis, labels, and a title. Okay? If you look on the slide, you will see an example of a graph. It's not a perfect example, it's just, what would you say, a planned graph, as you say, a planned diagram, meaning it is not precise, or it doesn't have labels, or it doesn't have all the properties. It is just showing you an outline of what a graph should be. Alright, so now we're going to move to one of our graphs, which is bar graphs. Now, we briefly spoke about bar graphs in our introduction, but we're going to go a bit in depth now. So bar graphs are used to display categories of data. A bar graph is one method of comparing data by using solid bars to represent unique quantities. Now, these solid bars are what gives the graph its name, bar graph. So if it was a circle or an oval or lines, it couldn't be considered a bar graph. All right. So these bars gives the bar graph its name. Now it shows the numbers that are independent of each other. For example, data might include the number of people who prefer Chinese takeaways, Indian takeaways, and fish and chips. Alright, looking at the example graph that I have on the slide, our title is nicest fruit, and we can already presume that this graph is going to tell us which one is the nicest fruit, which one is mostly preferred. So we see the number of people, and then we see the types of fruit. So the number of people is on the x-axis, while the types of fruits are on the y-axis. So we can see 35 persons prefer apple, 30 orange, 10 banana, and we can read the graph and see for the rest of fruits. Now, while reading this graph, we see how many people prefer a certain type of fruit. So it's representing the data that was collected. Maybe an interview was done or a questionnaire was done to get this information and to present it in a format that is easy to understand and easy to read. They put it into a graph. All right. So that's for bar graphs. So the other graph that we will be discussing is the histogram. Now the histogram is commonly mistaken with the bar graph, and this is because the histogram uses bars. But what makes them different? Now, the histogram is a special kind of bar graph that uses bars to represent the frequency of numerical data that have been organized into intervals. So here we see frequency and intervals that we did not see when we were speaking on bar graphs. So because the intervals are equal, all of the bars have the same width. And this just means that there is no bar that is wider than the other. That would make the graph inappropriate and inaccurate, so all the graphs have the same width. Because the intervals are continuous, connected or ongoing, there is no space between the bars. So this is also what makes them different. There is absolutely no space between the bars on a histogram, and this is just because the information is gathered in intervals. So it's 40 to 50, 50 to 60, or 39 to probably 49. Then we have 49 to 59, however you want to read it. In this case, on the graph that is being shown on the slide, we have intervals of 10. If we look on our x-axis, we see intervals of 10, even though the numbers are spaced in intervals of 20. So let's go. We have 40 to 50. Then the next bar starts at 50 to 60, then 60 to 70, then 70 to 80, and so on until we reach 140. So this is just an example of how the bars are connected through the use of intervals, and you see there's no uneven interval there. So it's not an interval of 10, then an interval of 15. It's all intervals of 10, and that's what I don't know what's happening, and that is what keeps our histogram a histogram. Equal amount of intervals and no space between our bars, and it's as simple as that. Now this graph doesn't have a title or any labels on our axis, but that is fine. It's just to show how the connection and interval works. So our next graph that we'll be moving on to is line graphs. Now usually line graphs are used to represent, or graphically represent I should say, rainfall patterns. So it represents a lot of other patterns as well, but it's typical for rainfall patterns. So let's look at the graph that is on this slide. So here we see on our y-axis precipitation in millimeters, and on our x-axis the months of a year. So let's try to interpret it. So in January, precipitation was between 100 and 150, approximately 125 millimeters. February, it could be approximately about, let's say, 70 millimeters. So we just look where those thick red square dots are, and then we can see, or we can assume appropriately the amount of rainfall for each month. And usually after looking at many line graphs of rainfall over area, you can say, all right, in December rainfall will be between 150 to 200, or in October it's a higher chance of precipitation or higher amount of rain falling, so we know that it's 250 and higher. So that's how it predicts patterns, especially in rainfall. So line graphs are used to display continuous data. So this is also a graph that's used to display continuous data. It is different from the histogram because one, it doesn't have any bars and it doesn't work in intervals. It's a bit different, but the information is still continuous. So line graphs are useful in predicting future events when they show trends over time. So this is usually our pattern graph. So it establishes a pattern and in that case can predict future events. Okay, now we're at our final graph, and this one is different because of its name. It's called a pie chart. Not a pie graph, but a pie chart. And usually persons may see pie chart and say that's not a graph because it doesn't have graph in its name, but that does not make it less of a graph. Alright, so let's talk about our pie charts. So they are used to show a relationship of the parts of a whole. So percentages are used to show how much of the whole each category occupies. Now, usually when we're doing a pie chart, we do not use whole values, we use percentages. And this is because it's considered one whole is 100%. So when we separate our whole, we should get different percentages to equal to 100%. So if we do a pie chart and each section of the pie chart, when total does not add up to 100%, the pie chart is inaccurate. Let's evaluate this graph that is on the slide. So our title is student grades, so automatically we know now that we will be seeing the grades of students and how they are divided. So it's divided into A, B, C, and D. So we're going to see the amount of students who got A versus B versus C versus D. Looking at it, we can see majority of students got B, and then we look at our percentage of 42.9% got B. 12 persons in the class, which equals to 42.9% got B. Then the next one that's shouting out at us is C. So 10 persons in the class got C, and that equals to 35.7% of the class. Then we see that 14.3% of the class got A, and only 4 persons got A. Finally, we have D, and that's where least of the class is ranging at, and only 7.1% of the class got D, and it was just 2 persons. So we see how the amount of students in the class were broken down into different percentages. So we can add this up and see how many persons were in the class if that information was not given, and we can see how the percentage of the persons differ. Alright, so we know already that more than half of the class got B, C, and D. Alright, and less than half of the class, we could probably even say a quarter of the class got A. Less than a quarter of the class got A. So after reading the chart, we can gather a lot of information, and we can assume a lot of stuff if the information was not given to us. So usually when we have a pie chart, it's good to use percentages when writing on this graph because whole numbers would be invalid. Alright, and that is our final graph that we'll be looking at, and these are just the 4 main graphs. The 4 main graphs that we will see throughout most of our time, in general. We also have different graphs, scatter diagrams, we have bar charts that are horizontal. We also have different types of line graphs, one that has rainfall and temperature, different stuff like that. But I'm not trying to go that deep, I'm keeping it base level. So thank you guys for watching. Remember to like, share, and subscribe. And we're still in quarantine, although Jamaica will soon be getting back into business. But remember, at all times, stay educated. Thank you guys again for watching.